Thank you, Invide Labs, and thank you, Pradeep, for inviting me. I hope this talk is going to be useful to you. I'll try my best to explain the architecture to you and how it actually works. So let me just get started. Let me share my screen. And there we go. So great. I hope you are able to see my screen. And great. Okay, so great. If I get a feedback saying that my screen is visible, it'll be great. Pradeep, am I audible?
Yes.
Visible?
Yes.
Perfect. All right. So first of all, let me introduce what exactly is DejaView. DejaView is an SDK for the computer vision. So we are taking out the pain of doing the machine learning, deep learning for an engineer or for a developer, for an app developer, so that they can just quickly focus on their use cases. Let me go over the flow of the talk. The talk is going to be structured around, I'll introduce myself, and then I'll talk about DejaView and then show you how it works. And then after the demo, I'm going to get into the architecture details. So stay put till the end. I'm going to explain to you what exactly is the key ingredient for the machine learning or the AI in these models. Second part I'm going to talk about is the DevOps or the architecture part of it. So it's a heavy engineering work, and with this knowledge, you will be able to build a lot of great stuff. And let me move ahead. So I'm Sandeep Giri. I'm the founder for DejaView and CloudX Lab. I long back graduated from IT Rookie, have worked on large-scale computing as well as machine learning at Amazon and Moby and started my own company before CloudX Lab called T-Bits Global. And then I basically love software engineering, and I love explaining technologies. And that's the reason why I started CloudX Lab, and that's the reason why I'm speaking on Git Commit Show today. All right. So the purpose of Git, so the purpose of DejaView is that to make the computer vision is meaning the ability of the computer to see, to perceive. That's one of the key sub-objectives of AI. So the purpose of DejaView is to make the computer vision as SDK or an API, so that the developers don't have to do all the heavy lifting of deep learning, machine learning, and they don't have to do all the DevOps and deployment or scaling work. And it requires the knowledge of ML. All right. So it all basically they don't need to maintain or create such kind of infrastructure. So that's the idea. Essentially, in DejaView, the main idea is making the vision part of AI pluggable, so that you can plug and play the AI part. So for building an AI app, what you need is powerful machine learning model, huge infrastructure, and expertise in the domain of scaling as well as in the domains of machine learning. So the existing solutions require the developers to know about what is ML, how to scale it, how to deploy it, and so on. And at the same time, it requires the developer to launch a lot of infrastructure, right? It has to have various kinds of services and so on. I'll go into those details. At the same time, the existing solutions are not offering that great precision. So I, along with Praveen and Abhinav, have started DejaView, and we're focusing more on deploying it for free in the beginning. So let me just give you a demo so that you can get an idea about how it works. All right. So imagine that you are running a shop. Okay. You're running a shop, and you, if you go to the website, it'll ask you to sign up. So this is my shop, right? So when a new customer or new user is coming to my shop, I'll just say capture, and it'll recall if the person exists in the database. So I exist in the database, in these photos. So it has recalled that part. So you can try setting up your shop and try to store the information for the first time, and then it'll be able to recall who it was. So this way you can easily build a zero touch front desk for your company, for your shop, for your building, for your school, and so on. So with this, it basically keeps on storing you can keep on storing the details about the person who is walking in. If the person is not found in the database, it asks you to store the person in the database, and then all you have to do is just click on capture, and the person's photo will be captured and recalled. This way, you don't need to remember everybody's face, and you don't need to rely on memorization of everybody's face. So this is essentially extremely useful for many use cases. Like for your offices, you can have you can build a front desk very quickly. At the same time, if you are running a shopping store or a supermarket, you can build the loyalty programs around the face. And if you are running, you have for the hotel industry, the experience could be customized based on the person's face. It could remember that the person came on such and such date in the past, and these many visits have been there based on the face. And this way, you'll be able to customize the experience of the individual, that this person likes the AC to be cold or to be high, and the temperature of baths should be this much, and so on. So you could do a lot of customization without bothering the individual about his details. At the same time, you could do the classroom attendance and so on. So, and at the same time, you could build your own solution using the SDK provided by DejaView, and you can fit in new use cases as per yours. Right. The way it works is, first of all, there's a user authentication. Then once the user authentication is successful, this is happening from the API end. So your API is going to our website, doing the authentication, and then uploading a picture. And then the server is internally running the neural network, extracting the face embedding, and then here get the existing faces from the database and figure out which one is the closest, and then find the closest face. Now, in this, the main problem is that this part takes a long time to load and doing the inference. And then second part, that it is most of the maximum time is taken by this part. So this and this combined together takes usually more than 3 to 4 seconds. But what we have done is, by clever optimization of these two things, we have brought down the overall time of finding the closest face based on the image. We have brought it down below 1 second. So that is something that we have done. Actually, it's around 0.3 overall seconds. So try it out. This itself was taking earlier more than 5 seconds. So we basically brought it down to very small. Even in the worst case scenario, it's going to do pretty well. All right, so I'm going to go into more details about the architecture. But before that, I would like to explain to you what exactly is embedding. The way embedding works is that essentially embedding is generated by a neural network. Neural network takes a photo and converts it into numbers. The way these numbers are produced usually is by the way of a neural network. Specifically, there's a neural network called, I think, DeepFace. It's called FaceNet. FaceNet is the neural network under the hood. So what FaceNet does is it takes the photo, converts it into these 100 numbers, right? So just like my height can be represented by one number, but my running speed or my general abilities are very hard to be represented in a single number, right? Just by looking at my marks in maths, you cannot judge me, right? Therefore, to judge me, you need to know a lot more numbers about me. Similarly, to judge a face, you need more characteristics. You need minimum of say 100 or 128 characteristics. So these are, and again, it's very hard to answer right now that whether 64 is good enough, 50 is good enough, or 128 numbers are good enough. But for this discussion, let's just keep it 128 numbers, because that was what it was done. Okay, so another question that you guys might be having is that where do these numbers come from? Are they representing the size of eyes? Are they representing the size of my chin? What is it these numbers are representing? Okay, quick answer is nobody knows. Not even the people who built the FaceNet, they also don't know. What they did was they built this optimization system by the way of machine learning that generate those 100 numbers, which would be close by to each other if the two faces are same, and these 100 numbers will be far away from each other if it is shown the photos of a different person. All right. So come up with those 100 numbers which would be close by for same person's face. Close by as in take 100 numbers, do a Cartesian distance, and that's the distance between the two numbers. So for the same person's face, this distance should be very small, and for different person's face, this distance should be big, right? So the idea was to figure out these numbers to represent the faces. So what they did was they gathered lots of faces of one person as well as lots of faces for other persons. So many people's faces they gathered along with multiple photos at multiple ages of the same person wearing different things. And using that, these neural network was built, which could convert the face into these numbers. All right, this is called face embedding. So this is another example of face embedding. And probably in the previous talk, somebody was demoing the idea of the embedding using don't touch your face, right? It's the same embedding here also. We call it transfer learning, pre-trained neural network, and so on and so forth. Right? So the main idea here I'm trying to show you is that let's say this is Sandeep Giri on the right-hand side. On the left-hand side, you see these actors. Now I want to find out which actor is closest to me. So all I have to do is convert each of these faces into these numbers and compare this against these. So either you could do a comparison, or you could again utilize the machine learning models such as KNN or SVM to find out which one is closest to my face, right? So you could, I mean, for the discussion's sake, let me just say that let's just compare these numbers against each of these faces. And I found that there's somebody called Suraj Sharma whose embeddings are very small, closest to my embeddings, and actually he looks like me when I was younger. All right, so this is how embeddings work. So converting face into 100 numbers is what embeddings is about. It's called transfer learning, it's called pre-trained neural network, it's called FaceNet, it's called the AI behind the faces. So the most important part is to understand that a face can be converted into 100 numbers. Now, coming back to it, so the way the web application works is that users are making the API call, or the whatever call you can call it, right? So users are making API call, it goes to web application. In our case of DejaView, we are using Django, Python Django, and then there is a async call process in the midway, because this guy cannot keep waiting till the process finishes. So he drops the message here saying that your work is in progress, and then it keeps on polling here to observe when the work finishes. This async call process, on one hand, talks to this service called image embed, which converts image to embedding. So this one keeps running parallelly inside the Docker instance, which is running the Kubernetes cluster, right? So this way, as the data increases, this will keep on scaling, and therefore it is infinitely scalable. On the other hand, there is a database of the users, which is already holding the embeddings of the users. So So one call goes to the Docker asking for embedding, other call goes to this NoSQL data store to bring the information about users. And then notice this, that we have made it parallel, and you can also make it parallel, so that if this one is taking 1 second and this one is taking 1 second, overall time will be 1 second, not 2 seconds. Now, that essentially brings it down to 50%. Now, at this point of time, this process would become a big overhead, and therefore this will again have to be scaled just like this. So by the way of Docker and Kubernetes, you can scale it along with a NoSQL server. You can scale it to billions of users without too much of problems. All right. And this matching again is done using the TensorFlow and other tools. And that's how it works. All right. That's pretty much, you can learn more about machine learning, deep learning at CloudX Lab. I run my courses on deep learning, machine learning, as well as when people are performing really great in my courses, I generally absorb them into my projects. And DejaView is one such project. That's pretty much from my presentation perspective. I'm open to questions now.
Perfect. Thanks a lot for sharing your project with us. So to the audience, you can ask the questions in the question answer chat section on live.gitcommit.show. If you are watching it somewhere else, please go to live.gitcommit.show and ask the questions. So first question I have is, what was the most important decision that bring down the time, as you said, from 5 seconds to 0.3 seconds?
Converting the deep learning whole neural network from a web application into a service. That was the most important decision taken. That basically brought down the time drastically. Something that was taking more than a second, it came down to 0.3 seconds suddenly. It was actually taking around 3 to 4 seconds, and it brought it down to 0.3. And essentially understanding how does the neural network works was most crucial part of it. And when you have services, when you have these modular components, what you can do is this part is running in Python, this part is running in C. So wherever you feel that the process is going to take more time in Python, let's say I'm comparing a million pixels against million pixels. In those cases, I don't have to do it in Python. You can just use a TensorFlow or other APIs and use that as a service. So developer engineering is something that is crucial in case of even machine learning models, because machine learning models, you're not going to improve it. Trust me on that. They are going to be there. But what you can work as my message to the software engineers around is that if you understand the engineering around it, you can actually solve a lot of the problems. If you see the progression of most of the machine learning models, most of the time it's actually the engineering. Most of the time it's not sciences, or it's not the neural science study.
I see. So now we have DejaView SDK, which people can use if they want to implement face recognition, and it's highly performing SDK, right? And what is the resources which are needed to use this SDK? Like, what kind of machine do I need? Do I plug in an AWS machine, or do I plug in a GPU, or how does it work?
From the users of DejaView perspective?
Yes.
Okay. So basically, if you have a web app or mobile app, just like the way you embed Google Analytics, right? In the same way, you can embed DejaView into your mobile app or web app. You really don't need any heavy lifting on your side. You can focus on your business logic. You can focus on your user behavior, and you can leave the face recognition and other AI to DejaView.
Got it. I have a similar question we have in chat. Well, how does SDK works So I think that's what you have answered. Do you have anything else to showcase how it works, or?
I'll probably publish the documentation very soon. If you have any questions, reach out to me at Sandeep at CloudXLab, or reach out to me at LinkedIn, and I would love to give the details. So I'm basically right now having a little private selected kind of demo, the beta invites I'm running for privately selected people. If you want an invite, just drop me a message at Sandeep at CloudXLab, or send a message to Pradeep. Probably that will also be good.
Great. Do share that. So we will share the presentation or any other material that is needed to anyone who is interested in this project or want to build their own project to using DejaView. So we'll share that information on our GitHub repo. And meanwhile, what are the alternatives to this?
Alternatives to DejaView is that you can build by yourself. Exactly what I explained to you just now, using say AWS, Google, GCP, or using their SDK, you can build all of this. But again, it is just too much of heavy lifting, unnecessary. Okay, specifically such kind of optimizations, they have optimized on the machine learning part, but not optimized on the overall mechanics part, right? So it'll take more resources and will burn a big hole in your pocket, as well as at the same time, it is going to be, how should I say, it's going to take more time in each face recognition. So you can build, to achieve what we have done, you probably have to do it at your own and using whatever I've explained so far, or you can just use DejaView. So as of now, it might seem that AWS or GCP or Microsoft have an alternative, but no, they don't. Try it out. You will know it very soon. Probably the previous presentation and other, if you notice, most of the engineering is done by the engineer, not by the services or not by the neural network.
Got it. So one last question is, we have a theme for this conference, Pursuit of Mastery, and you have a great track record of working at different organizations, building machine learning projects, teaching people about machine learning. What is your learning about related to this topic, or if you want to share any thoughts on the theme?
The theme is
Pursuit of Mastery.
Pursuit of Mastery. Okay. So honestly speaking, if you have to do really good, let's say machine learning, most of the time the machine learning is about good engineering. Okay. And my recommendation to probably every engineer out there would be to focus on let's say data structures, algorithms. At the same time, focus on learning Linux really well, and and along with that, basic maths you should be good with, and then you will see that there'll be a lot of doors open. So even though the bigger things like DevOps, like machine learning, they might look really complex and big things, but if you master the basic components, such as you should be good with data structures, algorithms. You should be good as in you should be okay with most of it. I'm not saying that you should be perfect, right? As well as you're good with, say, Linux, understanding of Linux, and so on. So remaining parts will be covered really well for you. Okay. And you don't have to panic that you are left behind so much. No. The thing is that those fundamentals is something that make a big difference. Even in case of DejaView, even anything that we have built so far, those fundamentals is something that plays the key role, because once those fundamentals are clear, you will be able to learn anything for that matter. Like, for example, learning Docker and Kubernetes requires a good knowledge of Linux, for example. So if you're comfortable with Linux, those skills you can pick really fast. right? And if you're let's say good with basic coding and Python and churning data and so on, you'll be able to pick up the machine learning application point of view very quickly. But if you're good with maths, a bit maths and how the algorithm work, sorry, if you're good with maths, let's say how Tyler series work or things like that, you will be able to quickly pick up the entire science behind the machine learning. So my recommendation would be that you clear the basics, not like basics, entire basics, just these basics like Linux and a programming language, and along with data structures and a bit of maths. That's it.
Amazing. So thanks a lot, Sandeep, for joining us and sharing your project with us. It was great to have you and learn about how you made this face recognition app. And I'm also excited now to try this out and probably see how it works from the inside.
Great. Wonderful. Thank you, Pradeep.
See you. Bye bye.